Hello friends, this video on statistics part 13 is brought to you by examfear.com. No more fear from exam. Let's understand the concept of the central tendency. Let's take a situation where there are two students, Mary and Hari. So this lady is Mary and this guy is Hari. And they got their marks. So they attempted a maths test. It had 5 questions. Question number 1, 2, 3, 4, 5. Mary's score was 10, 9, 10, 8, 9, 8, 7 for all these questions. And Hari scored 4, 7, 10, 10, 10 in all these 5 questions. And they received their score. Now the question is, who scored better? Mary claims that she scored more. Hari told that he scored more. How to justify who scored more? See, in this case we can plot a graph, but I don't think we'll not be able to conclude that who scored more. We'll not be able to conclude that, right? So if you take the average score of Mary and Hari, that will be mean here. So let's take average score. So average score of Mary, and I'm talking about mean. Mean is nothing but the average score. Will be what? Add all this. 10 plus 8 plus 9 plus 8 plus 7. 10 plus 8 plus 9 plus 8 plus 7. And you divide by 5. Right? What you get is 42 by 5. And that is 8.4. And let's find average score of Hari. That will be what? 4 plus 7 plus 10 plus 10 plus 10. 3 times 10. 4, 7, 3 times 10 divided by 5. That is nothing but 41 by 5, and that is nothing but 8.2. So average score of Mary is more than average score of Hari. So Mary claims that no, since he has got a more average score, that means he has scored better. She claimed that she scored better. But this guy Hari didn't agree. He told, okay, let's arrange this data in the in the ascending way, right? So for Mary, the score will be what? The minimum score is what? 7, and then 8, and then 8, and then 9, and then 10. For Hari, the minimum score is 4, and then 7, and then all 3 10. So he told, let's arrange in the ascending way. Now he told that let's take the middlemost score. So as per the middlemost score, Hari has scored better. And when talking about the middlemost score, he is talking about median. He is taking, let's take the middlemost score, and with that also with that data I scored better. That means Hari scored better as compared to Mary if you talk about the median. Still the Mary is not convinced. Okay, now Hari told, okay, let's do one thing. Let's see what is your most often score. So for Mary, the most often score is 8, and that's where we're talking about mode, right? Most frequent, and this is middle number, and this is average, right? So most frequent score is 8. So, and for Hari, the most frequent score is 10. So with that also, Hari is telling that, Hari is claiming that he scored better. But who scored better? I mean, still we don't have a data, right? So if you talk about from the mean perspective, Mary scored better. If you're trying to find the median of this number, Hari scored better. If you're trying to find the mode of the number, Hari scored better. Because if you see 3 questions, Hari scored 10 out of 10. That means Hari is a consistent performer. One question Hari scored 4, maybe he was not very comfortable or something happened, right? So you can ignore the extreme case. So looking at various aspects, right? So we can say that, yeah, Hari may have scored better, more consistent, more 10s, right? More 10 out of 10. So with that data, I mean, still we don't have a concrete answer to say who has scored better, but there are 3 different ways of looking at the data in this case. And all these 3 are talking about the central tendency of the data. The first actually mean takes the average of the number, right? And mean is denoted by x bar, that is mean. Okay, so it will tell you the exact average. Median will tell you where the central number lies. For example, in this case, median is 8. That means 50% of the number is less than 8, 50% of the number is more than 8, something like that. And mode tell you which number is most frequent. Which number is most frequent. So we'll see application of these three terms, mean, mode and median. All these three actually depicts the central tendency of a given number, right? So let's take a few more examples to understand what is mean, what is mode, what is median, and where should we use these three terms. Okay. So central tendency, as I told, is nothing but it is a measure that tells us where does the middle of the bunch of the data lies. Okay, and three most common central tendencies are mean, median and mode. Mean, median and mode. So let's take one scenario. There are two students, Ram and Sita, right? And let's suppose they have their worksheet, study hours, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Okay. So the data is given. For Ram, let's suppose it is 5, 4, 4, 3, 2, 5, 5. For Sita, it is, let's suppose, 4, 5, 2, 3, 4, 4, 5. Now the question is, who studies more? Looking at data, it is very difficult to say, right? Someday Ram is studying 5 hours, someday Sita is studying 5 hours. It's very difficult to say. So let's find the average. So mean for Ram, we got 5 plus 4, 9, plus 4, 13, plus 3, 16, plus 2, 18, plus 10, 28. 28 by 7, that is 4 hours. Mean for Sita is what? 4 plus 5, 9, plus 2, 11, plus 3, 14, 18, 18, 22, plus 7, 27 by 7, that is 3.5. So if you see the average, from average you can see that yes, Ram studies more. Correct? So using mean, you can say that yes, Ram studies more. If you talk from the mode perspective also, let's rearrange the data in the ascending order. So it will become 2, 3, 4, 4, 5, 5, 5. So let's cancel this. So this data also gets arranged 2, 3, 4, 4, 4, 5, 5. If you actually rearrange this, you can actually see that the mode for Ram is 5, maximum number of occurrence is 5, and here the maximum number of occurrence is 4. From that also, if you see, Ram studies more. But if you take the median, in both cases it is same. But in this case, I think the mean is the best way to judge who studies more. Okay, let's take the average, simple average. We can make out, okay, who has studied more. But who is performing more, that is different, right? That with that is a different. For example, in the last example we took, right, test who perform more, better. That's different. But who, for example, who is studying more or who is getting more salary? For example, if I say that there are two people and their daily income is given. So one day is making 10 rupees, 20 rupees, 30 rupees, 40 rupees. The other guy is making 40 rupees, 30 rupees, 20 rupees, something like that. Who has made more money per day? That is the average, right? And then you can easily take the mean. So mean is something where you have to take the arithmetic average. This example where who studies more average per day, then it's the Ram who studies more. Right? You don't have to calculate other things as well. Median, good example of median. For example, you have to find the middle guy. So there are so many people standing. You have to say who is the middle guy. Means who? Tell me the guy. 50% of the people are taller than him, and 50% of the people are shorter than him. then you have to arrange these people in the ascending order, right? And then you will see that this lady is the middle, correct? So this lady is the middle lady and she is the median. So 50% of people are shorter than her, 50% of people are taller than her. Typically median are used in this kind of scenarios, correct? Mean is typically pure arithmetic, average. Median is typically used to find the average middle guy. So let's see why median. See, the advantage of median is it actually ignores the extreme value. It ignores the extreme value. It helps sometimes to find the performance. If you want to find the performance of a cricketer, then you may want to ignore the values, extreme values. Someday he didn't perform well. I'll take an example. And it tells the point from where 50% of the data is lesser and the 50% of the data is more. Let's do a quick comparison of mean and median. So median ignores the extreme value and it tells the point from where the 50% of the data is lesser and 50% of the data is more. But mean is actually an average. It gives importance to all data. For example, if you see there is a cricket score for, let's suppose, player A. I want to see his performance. So let's suppose one day he made one run, then he made 51, 50, then 51, let's suppose, then 52, then let's suppose 53, then again 54, and let's suppose 55. This is the score he has in 7 matches. So if you find the average, if you find the mean, you add all these and divide by 7, you get 316 by 7, that is 45. Mean score comes out to be 7 for 45 runs. But if you find the median is the middle value, that is 52. And if you see in this case, what do you think? What is the number which actually depicts his performance? Is it 45 or 52? I will say 52. See, why? Because one day he scored one, maybe it was his bad luck, right? Maybe he was not well, something happened that he got out in one run. But other days, if you see consistently, he's making 52, 53 runs, 55 runs. So here in this scenario, at least, I feel that median is a better representation of central tendency. Median is a better representation of this data. For example, for this cricketer, if somebody asks me, what is the value? I'll not tell, okay, he's played 7, or let's suppose it is 700 matches instead of 7. So you'll not say he has played 700 matches and this is the score in each match. You will just say what is the average score, like not the average, what is the median score, what is the score typically he makes. Then it will be 52. It will not be 50, 45 because typically he makes 52. See, one run he has made, that is extreme case, is a very not so probable scenarios. And if you see in case of median, these values are ignored. These values are ignored. Right? So that is the power of median. So it will ignore the extreme values and it will tell you place from where 50% of the data is lesser and 50% of the data is more. So in case of this kind of scenarios where you want to gauge the performance of a cricketer or anyone else, right? You gauge the beauty of someone, right? Who is more beautiful, less beautiful. In that kind of scenario where the mathematics doesn't play much role, performance, beauty, all those things, there we use median a lot. For example, in this case, the mean is not giving me correct data. Okay. Let's take example of mode. For example, if you want to know which is the most favorite subject for a given class, so in class there are 5 students, then student A will say or said math is his favorite subject or favorite subject. For student B, physics is the favorite subject. For student C, again maths. For student D, English. And for student E, again maths. So here you can't apply mean, you can't apply median. You have to go for mode. You have to see that, okay, maths is the highest number. So math is most frequent. Right? So here the mode is maths. So in this kind of scenarios, we use mode. So hope you understand the scenarios where are we going for mean, where are we going for median and mode. And there is no hard and fast rule actually. Right? There is no hard and fast rule. But The data is there. So now from that data, if you're looking for the performance, you want to ignore the extreme cases, then you may take the median. If you're looking for which is the best subject, which is the best teacher, which is the best product, which is the most frequent product or most frequent thing, then you have to go for mode. But if you want to get the actual average, what is the average income, what is the average salary, what is the average production, what is the average marks, right? In that case, you have to go for mean. So mean is more arithmetic. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attend free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.